Hey guys, welcome back. So today we're going to continue with object-oriented programming in the freeCodeCamp curriculum. Okay, before we get started, don't forget to hit that subscribe and that bell icon. Okay, let's get on with this. Let's go to the first lesson. So we want to create a basic JavaScript object, and we can do it like this. We can give them properties and behavior. So let's just create a dog object with a name and numLegs properties and set them to a string and a number respectively. Okay, so we can do it like this. Name going to be Pierre. Okay, and num of legs is going to be 4. Yeah. Oh, I forgot we need to do it like a Python dictionary. Okay, great. Let's continue with the next one. We need to use dot notation to access the properties of an object. Okay, so we need to print both the properties of the dog object to the console. It's pretty straightforward. Dog.name, and let's do the same for the number of legs. Okay, great. Now, how to create a method on an object. So methods are properties that are functions. Okay, so here we have an example, say name. We just return the string the name of the duck is, and it returns the duck's name. Okay, we need to add the method say legs, which should return the sentence this dog has 4 legs. Okay, let's copy the sentence, and I'm going to say here say legs. This is going to be a function, and it returns this. Okay, this one should do it. Yeah. Let's continue. Now, how to make code more reusable with this keyword. Okay, so why do we use this? So this refers to the object that the method is associated with. Okay, so in this example here, let's see. So inside the method say name, we are using the keyword this.name. So this in this case represents this instance of duck. Okay, this duck with this name, this specific duck. Let's see. We need to modify the dog say legs so that to remove any reference to dog. Okay. So in here I'm just using this keyword. Okay, great. Now we need to define a constructor function. So constructors are functions that create new objects. We define properties and behaviors that will belong to the new object. So it's like a blueprint for creation of new objects. So let's see, here is the example of a constructor. It's a function, bird, and we have the properties here. Now we need to create a constructor dog with properties name, color, and number of legs that are set to a string and a number respectively. Okay, we can do the same as with bird. So this is going to be a dog, and it's going to have a name, a color, and number of legs, which is going to be 4. Color is going to be gold, and the name Bjorn. Okay, great. So how to use a constructor to create objects. Here we see using the bird constructor with a new keyword, it will create a new object. Okay, so a new instance of bird. We are going to use the dog constructor to create a new instance of dog, and we're going to assign it to a variable called hound. So let hound be new dog. Okay, and this one should do it. Yep. Now we want to extend constructors to receive arguments. So if you want, when we create an instance of bird and we want to give it a name and a color, we can give them as arguments to the constructor. Okay. So let's create another dog constructor, and this time we set it up so it takes the parameters name and color. So it will take name and color, and okay, and have the property number of legs fixed at 4. Now in this case we will do something like this. So this dot name is going to be name, and this dot color is going to be color, and this dot num of legs is going to be 4, fixed for every instance of dog. And now let's create a dog. So we will create a terrier. It's going to be new dog, and I'm going to give the name and the color. Okay, and the name is going to be Björn and cold. Okay, yeah, great. Now, how to verify an object constructor with instance of. So anytime a constructor function creates a new object, that object is said to be an instance of its constructor. So we have a convenient way to verify with the instance of operator. We can use instance of to compare an object to a constructor returning true or false based on whether or not that object was created with the constructor. Okay, so here we have the bird constructor. We create a new bird and save it into the variable crow, and then we can say crow instance of bird and it will return true. Let's create an instance of house constructor, calling it my house. So let my house be new house, and it gets the number of bedrooms 2. And now we're going to use my house instance of house. Okay, we can do this, yeah, instance of with a lowercase o. This one should do it. Yeah, great. Now, so let's see. Name and num legs, for example, for the bird constructor are called own properties because they are defined directly to the instance object. Okay, so that means that duck and canary here, which are created using the new keyword with using the constructor, they have their separate copy of these properties num, so that makes them own properties. Okay, so okay, every instance of bird will have its own copy of this property, so the following code adds all of them own properties of duck to the array own props. So here we have an array own props where we store the own properties in the of the constructor. Okay, we need to do the same. We need to add the own properties of canary to the array own props. So let's see. we need to iterate property in canary. So we can iterate through the properties of the canary object, which is created with a constructor bird. And if we can say canary dot has on property. So has on property checks if this object has this property, has this own property, and it returns true if it does. So if it does, we want to do own props dot push, and we push the property. Okay, so it's the same as in the example for the duck. Let's see. So we are iterating here. Okay. I think this one is the issue. A typo. Great. Okay, so now we're going to learn to use properties to reduce duplicate code. Okay, for example, the number of legs will have the same value for all instances of bird. So we essentially have a duplicated variable number of legs inside each bird instance. Okay, better way is to use bird's prototype. So properties in the prototype are shared among all instances of bird, and we can do it like this: bird.prototype.numLegs equals 2. Okay, so since all instances automatically have the properties on the prototype, think of prototype as a recipe for creating objects. Okay, so for example, the prototype for duck and canary is part of the bird constructor as bird.prototype. Nearly every object in JavaScript has a prototype property, which is part of the constructor. Now we need to add the numLegs property to the prototype of dog. We can do it like this. Just dog dot prototype dot numLegs is going to be 4. Okay, great. Now let's iterate over all properties. We have seen so far own properties and prototype properties. Okay, own properties are defined directly on the object instance itself, and prototype properties are defined on the prototype. So here's how we add duck's own properties to the array onProps and prototype properties to the array prototype props. So like this, we check if a property is in duck, and has own property returns true if it is an own property, and if it is, we push it to the array onProps. Else, if it isn't an own property, then by default it's a prototype property, so we push it into the prototype props array. Okay, so we need to add all own properties of the beagle to the array onProps, and the prototype properties of dog to the array prototype props. Okay, let's see. We want to iterate through let property in beagle, all the properties in beagle, and we're going to do the same like this. So if beagle dot has own property, and we're going to check for the property. If it is true, we want to push it to the onProps, property. Otherwise, else we want to push it to prototype props. Prototype props. Okay, let's run this. Great. So the constructor property. So let's take a look at it more closely. We can use we also have a constructor property. So it just checks, it just gives you back the constructor for this object. So we can check the property. We can check this property to find out what kind of object it is. So let's see. We have this function join birth fraternity, gets a candidate, and if candidate.constructor is equals triple equals birth, then we return true. Okay. So the constructor property has an issue that it can be rewritten, so it's better to use the instance of method to check the type of an object. Okay, anyway, let's write a function that takes a candidate parameter and using the constructor property returns true if the candidate is a dog, otherwise returns false. So in this case we want to check if candidate.constructor equals dog. We want yes, and if so we want to return true, or we can write this really in a shorthand. Just do this. Yep. This one will return true or false. Great. So how to change the prototype to a new object? Okay, so we have added properties to the prototype individually like this, but this is very tedious. So we have a more efficient way to set the prototype. We can define the prototype like this. Okay, so like we did with an object. So in this case we have a bird prototype which has a property number of legs, an eat and a describe method, which are prototype methods. Okay, we need to add the property number of legs and the two methods eat and describe to the prototype of dog by setting the prototype to a new object. Let's see. So num of legs is going to be 4, and then we also need an eat and describe. Eat is going to be a function. Console.log. Let's do it the same. And also we want a describe. It will be a function, and it's going to console log. My name is plus this dot name. Okay, so this is accessing the name for the instance of dog. Let's run this. Okay, great. Now we need to remember to set the constructor property when changing the prototype. Okay, so when we manually set the prototype to a new object, it erases the constructor property. Okay, so this was the property used to check which constructor function was created this instance. Okay, So to fix this, whenever a prototype is manually set to a new object, we need to remember to define the constructor property. So constructor, we need to add this line, constructor bird. So this was going to be like a prototype property for bird, and it's going to have the name of the constructor. So for the dog, we need to do something like constructor is going to be dog. So this, like so. Okay. So where an object's prototype comes from. So just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. Okay, so if we use the bird constructor to create the duck object, the duck inherits its prototype from the bird constructor. And we can show the relationship with the isPrototype of method. If we do bird.prototype.isPrototype of duck, it should return true or false. In this case, it returns true. Let's check if Beagle's prototype, let's see which is the prototype of the Beagle. So, and we need to check if dog prototype is the prototype of Beagle. Type dot is prototype of, and I'm going to give Beagle. This should return true. Okay. Now the prototype chain. Okay. So all objects in JavaScript, with a few exceptions, have a prototype. So an object's prototype itself is an object. Make sure to read this through on your own so you understand better and try many more examples. So here we have a constructor bird, and we can use type of bird.prototype. It returns an object. It is of type object. So because prototype is an object, the prototype can have its own prototype. So in this case, the prototype of bird prototype is object.prototype. Well, okay. So if we remember the has-on property, for example, duck has-on property name should return true or false. Has-on property method is defined in the object.prototype, which can be accessed by bird.prototype, and then that can be accessed by duck. So this is the prototype chain. Okay, bird is the supertype of duck, while duck is the subtype. Now we need to modify the code to show the correct prototype chain. So here we have a dog constructor. We have created a beagle, which is an instance of dog, and dog.prototype is prototype of beagle. Then this one yields true, and we need to check if object.prototype, in this case, dot prototype is prototype of dog.prototype. This should return true as well. Okay, great. Now we've gone to inheritance, but I think we should stop here for this video and continue with the rest of object-oriented JavaScript in the next one. Okay guys, thank you for watching again. Don't forget to like, share, subscribe to support the channel. I'll see you in the next one. Bye bye.